As we have configured HDFS successfully, let's start HDFS and also validate by copying some files. First, we need to ensure environment variables such as path are updated with bin as well as sbin folder of Hadoop. You can actually go back to the terminal and run echo $path like this. You can hit enter. You should be seeing these bin and sbin added to path. You can actually say ls-ltr and then copy this path and paste it. You can see the files related to HDFS and yarn executables here. Similarly, you can also run ls-ltr on sbin. Sbin is nothing but script-based executables. S stands for script in sbin. Now you can see a bunch of shell scripts here. We should be able to use scripts such as start dfs.sh to start HDFS components, stop dfs.sh to stop HDFS related components. We will run these shell scripts in a moment. First, we need to ensure that the parent folder of the scripts is part of $path. It is the case. We have already validated by saying echo $path. I am running once again. You can see the opt hadoop has been part of $path, which means we should be able to run these commands from anywhere. As we have validated this, the next step is to validate that we have passwordless login within the server by using the same user who owns OPT Hadoop. In my case, OPT Hadoop is owned by itversity. I should be able to log in onto the server using itversity as the user without entering the password. I should be able to run this piece of command to validate the passwordless login. I have already covered how to set up passwordless login earlier. This will confirm that the passwordless login is set up. You can see that it have launched another session with the same user and the server name. Now I should be able to say exit and come out of this. Now we should be able to run this command start-dfs.sh. It will take care of starting name node, secondary name node and data node. There will be 3 components with respect to HDFS that will be started when we run this command. You can validate by running JPS once the command is successfully run. If you run JPS now, it is not showing anything related to name node or secondary name node or data node. But if I say start-dfs.sh and hit enter, it will take care of starting name node, secondary name node as well as data node. If you do not have passwordless login, this time these will fail. And that's why it is very important for us to actually set up passwordless login before getting into starting this script. Now the script ran successfully. You should be able to validate whether all the components are started properly or not by running JPS here. You can see there is a process related to name node, secondary name node and data node, which means start-dfs.sh have started all the components successfully on this single node Hadoop cluster. As HDFS is started on this machine, now it is time for us to validate. You can actually say HDFS dfs-ls and then / at the end to confirm that we are able to access HDFS. As of now, we haven't created anything yet in this HDFS. That's why it is not showing anything as output, but it is not throwing errors also. As we do not have anything, it is just returning nothing. If we create something, it will start reflecting as part of this. So first, let's create a folder by name /user/itversity, the same user what we have here. For that, we should be able to run this command hdfs dfs-mkdir-p /user/$user. It will take care of creating a folder in HDFS by name /user/itversity. Once the directory is created, we can validate by saying HDFS dfs-ls. You can see that it is returning user. If you say /user, it will return /user/itversity. Now we have created a folder in HDFS. To make sure we can even have files in HDFS, I am copying all the files from this location. This is nothing but a local folder. Using -put, we can copy files from local file system into HDFS. We can validate the local file system by using ls-ltr like this. You can see there are a bunch of files in this. We want to copy all these files into HDFS. If you run this command, it will take care of copying the Hadoop folder itself, which contain all those files into HDFS by name Hadoop itself. Let me copy and then let me paste it here. This entire folder recursively will be copied under /user/itversity. You can run this. Then we should be able to run HDFS dfs-ls /user/itversity. You should be able to see the folder Hadoop in it. Let me say /user, then $user, hit enter. $user is nothing but a special environment variable in Linux which will reflect the user that is logged in. It is resolved to /user/itversity. You can see a subfolder Hadoop underneath it. You should be able to say /user/$user/Hadoop to see the contents of that folder. We can see all the XML files and properties files which are there under our local file system copied into this location. If you want to cat a single file, you should be able to run this command. We are catting coursesite.xml, which is there in HDFS. You should be able to say HDFS dfs-cat like this. You can see the contents of the file. It have one property which is nothing but fs.defaultfs. The value of that property is nothing but this one. Now, as we have validated successfully that we are able to copy the files from local file system to HDFS on single node cluster, I just want to clean up this folder. I should be able to say HDFS dfs-rm-R-skip trash so that the files will not be moved to trash. We just have to give the folder which we want to delete recursively. -R is primarily to delete the folder recursively. Now I should be able to paste it. Now the Hadoop folder will be deleted. We should be able to validate that the folder is deleted by running this command. You should not be seeing anything in this folder because we have cleaned up everything. This is how you should be able to start and validate whether HDFS is started properly or not on this single node cluster. So far we have downloaded Hadoop related binaries, configured HDFS, started HDFS and validated HDFS successfully. Now it is time for us to configure yarn and validate yarn.